So hello and welcome everyone. Welcome to Kreatryx. Welcome to Unacademy. So in these sessions, we are going to start the communication system and you are going to study the communication system like never before. So before that, let me introduce myself. My name is Vishal Soni and I have cleared ESE examination 2 times, both times in double-digit rank. And I have also served as a Group A gazetted officer in Indian Railways and in Indian Telecommunication Services. And I have also cleared a lot of public sector examinations. So right now I'm teaching on Unacademy and I really feel proud to be the part of the Unacademy team, because Unacademy is the revolution in the field of free education and in the field of affordable education, and we as a team are really looking forward for every student to just come onto the Unacademy platform. You can attend the special classes, you can come onto this YouTube channel and you can stay connected with us so that you can understand the quality education and you can understand the efforts that we are putting in, so that every student of this country, whether he stays in a village or he stays in a town, should get the access of the content, that too in a very affordable prices, and he can also or she can also clear the examination with the best possible ranks. So right now I'm teaching on Unacademy with more than 15 million watch minutes in the overall duration and 2 million watch minutes in the last 30 days. So I am right now the top educator in Unacademy across all the branches, having rank 4 right now. And you can also follow me on Unacademy on this particular link. So you can go and follow me on Unacademy. Apart from that, my advice to every student is that how should you crack the examination and what are the components to cracking the examination. So the first question that comes to the mind, that can anyone prepare from the YouTube? Yes, you can prepare from the YouTube, but you should develop or cultivate some habits in yourself. For example, you should be very much disciplined. You should arrange the extra resources. For example, the PDFs you have to arrange, the test series you have to arrange by yourself, and most importantly, that self-discipline you should be containing in yourself, so that you can be very corrective manner and you can approach the examination in the best possible manner. So all these things you have to arrange yourself. The sense of competitiveness you have to cultivate in yourself, because the audience on the YouTube are not that much of competitive in nature, or maybe you cannot feel the competition which is present right now. So all these things are the part of the journey if you want to prepare through the YouTube, or maybe if you want to prepare through the free resources. Apart from that, if you want that you should get complete content, then this is the YouTube channel. On this YouTube channel itself, all the free content are available. You just have to go to the playlist. All the subjects are completed there. You just have to go and watch all the lectures one by one. Definitely will be getting benefited. But the extra things that I have told you, that the self-discipline and the sense of competitiveness and a lot of things you have to arrange by yourself. If you are comfortable in that, then you can do that. Apart from that, you should also have Unacademy learning app, so that the special classes you can attend. A lot of educators in this country are actually providing the special classes, that too absolutely free of cost, so that you can get the quality content in the best possible manner. Apart from that, there is also another component for you, which is Unacademy Plus. So on Unacademy Plus, what is your job? You just have to study. If you join this Unacademy Plus, you do not have to worry about the crash courses, weekly test, doubt solving sessions, the language barrier, rank improvement batches, live classes. So all these things will be taken care by the Unacademy. You just have to take the Unacademy Plus subscription and you have to come on to the Unacademy. You will be daily getting the live classes. You will be getting the crash courses. When you will be getting the crash courses? When the syllabus are completed. You will be getting the weekly test in the form of quizzes. Every fourth class is the doubt solving session, which is the major you can say the component or the major impact will be creating on your studies will be this doubt solving group. Because until and unless your doubts are not being cleared, until and unless you are not able to clear your doubts, you will never get the confidence in the subject. So once you come on to this Unacademy Plus, every fourth class is doubt solving session. Apart from that, various other doubt solving sessions are going on. So ultimately you will be getting your doubts cleared and you will gain confidence in the subject. The language barrier will not be an issue, because the batches will be running both Hindi and in English, and rank improvement batches will also be there. So all these things are the component of this Plus subscription. Once you come on to this Unacademy Plus, you do not have to be worried about your self-discipline, your competitiveness nature. Everything will be present on Unacademy, because a lot of other students will be there. Since the classes will be live, you can also watch it recorded later on. So the discipline automatically comes, because you get the idea that you will be having the daily live classes. Apart from that, there is also one iconic subscription. In this iconic subscription, the game changer is this personal coach. So this subscription is for them who thinks that their basics are weak, or those who are talented but they needs a continuous push. So this personal coach will be guiding you throughout your study. He will be giving you the study planners. You will be getting the study booster sessions. Once you will get the test, you will be getting the analytics. Analytics plays a major role in improving yourself. We as a teacher also get our analytics so that we can improve on the daily basis. So once you start getting the analytics, you will be also improving massively on the daily basis. Apart from that, there will also be the guidance for the mains once you clear the prelims, and there will also be the guidance for the interview once you clear the mains. So once you take the Iconic subscription, all the benefits of the Plus are included by default in this. And if you take the Plus subscription, then also these things will be included in that, though, so that will also create impact in your preparation, so that you just have to.
Hello friends. So in the last class we studied about the noise, and we saw that white noise is nothing but a zero mean Gaussian random process, or it is a zero mean Whitesian stationary random process. So in this class what we will do, we will transmit this white noise through a LTI system. So this is your white noise. After processing this white noise, this system will generate another noise which I am denoting as N of t. So this is our LTI system. We can characterize our LTI system with its unit impulse response, or I can also take its Fourier transform. So now first of all, if this noise is white noise, which means it contains all the practical frequencies. So if you will filter out, then obviously it will not contain all the noises, so I can call it as colored noise. So whenever a white noise is passed through a filter, the result will be the colored noise. The colored noise basically means it does not contain all the frequencies or all the practical frequencies. This is zero mean Gaussian random process. We know that whenever a zero mean Gaussian random process is passed through an LTI system, the output will also be zero mean Gaussian random process. Now, if the input is zero mean WSSRP, then after passing through an LTI system, the output will also be zero mean WSSRP. Since it is zero mean, so we can say that if expectation of W will be 0, then whenever you will pass it through an LTI system, this expectation of N of t will also become 0. Similarly, since mean is 0, so you can say that mean square value of this white noise is always going to be the variance, and whenever you will pass it through an LTI system, the mean square value of this noise is also equal to the variance of NT. So these are the few important points which we have discussed earlier, and I'm showing you the results for this LTI system. So now let us understand. Suppose an LTI system is given. So this is the LTI system. We know its unit impulse response and its frequency response. The input is white noise, the output is colored noise. So this white noise I am denoting as WT, and this colored noise I am denoting it as NT. We can calculate its autocorrelation function, and let me denote its autocorrelation function as RW of tau. I can also calculate its autocorrelation function, and let me denote this autocorrelation function as Rn tau. Similarly, if I will take its Fourier transform, I will get the power spectral density of white noise, and if I will take its Fourier transform, I will get power spectral density of this. Now, you know that this will represent the power spectral density of white noise, and this will represent the power spectral density of colored noise. Now let us try to establish the relationship in between them. We already know that whenever the autocorrelation function of the output has to be written, you should write RW of tau convolution with minus infinity to infinity h of alpha h of tau minus alpha d alpha. This is the process. We know that for white noise, Rw of tau is going to be n naught by del tau. So I will put this value here. It will become n naught by 2 del tau convolution with minus infinite to infinite h alpha h tau minus alpha d alpha. We know that whenever you take convolution of del of t with any signal, we get back the same signal. So you can also write it as n naught by 2 minus infinite to infinite h alpha h tau minus alpha d alpha. So this expression will always give you the autocorrelation function of the output random process, which is n naught by 2 minus infinite to infinite h alpha minus tau d alpha. So this is the autocorrelation function of the colored noise or the output noise. So you can also write it as expectation of nt into n of t plus tau. Now if we have to calculate the mean square value of the output random process or Rn of 0, so it comes out to be n naught by 2 minus infinite to infinite h square alpha d alpha. And we know that if we have a signal h of t, and if I will calculate minus infinite to infinite h square alpha d alpha, it is always going to give me the energy of h of t. So here you will get the energy of h of t. So you can say that the power of output random process, which is expectation of n square t, which is nothing but its variance because it is a zero mean random process and it is Rn0. This you can write it as n naught by 2 minus infinite to infinite h square alpha d alpha, or you can write it as n naught by 2 into energy of signal h of t. So in this manner you can calculate the power of the output colored noise, or you can say that you can calculate its variance because the mean is 0, so you will calculate power or variance, both are going to be same. Now again, this is our LTI system and it has unit impulse response h of t and it's transformed as h of f. So this was the white noise and this was the colored noise. So we know that the PST of this white noise is SWF and the PST of this N of t is Sn of f. We know that output PST is equal to mod of HF square PST of input. So you can write it as Sn of f equal to mod of HF square SW of f. So this is the power spectral density of output process. Now if I have to calculate the mean square value of output or power of output or its variance, because the mean is 0, so it will always be equal to mean square value, then we can also calculate it by calculating the area under the curve of the PST. Now the value of this PST is mod of HF square into SW of f into df. We know that for white noise the power spectral density is always constant and that too equal to n naught by 2. So the value of this SWF will become n naught by 2. So I can write it as minus infinite to infinite n naught by 2 mod HF square df. So another way of writing the power of the output becomes expectation of n square t, which is P of nt, which is sigma square nt, or you can write it as n naught by 2 minus infinite to infinite mod of HF square df. So we have got two methods to calculate the power of the output random process n of t. So whenever you have to calculate the power of the output random process, it will always be equal to its variance, and you can follow these two methods. First method, you can calculate Rxx of 0, which is coming out to be n naught by 2 minus infinite to infinite h square alpha d alpha, or you can write n naught by 2 into energy of deterministic process or unit impulse response. Similarly, you can also write it as n naught by 2, or I should start from this, you can write it as Rn of 0. Similarly, you can calculate the power from the power spectral densities area under the curve, and this is coming out to be n naught by 2 minus infinite to infinite mod of hf square df. And if you will observe from the Parseval theorem that this particular expression is also representing the energy of ht in frequency domain. So you can also write it as n naught by 2 into energy of ht. So we know that whether we will calculate energy in time domain or frequency domain, as long as we are taking this from minus infinite to plus infinite, both are going to be same. So basically, to calculate the output of the random process and the power of the output noise random process, we can use these two methods. After discussing the basics of transmission of white noise through filters, now let us try to standardize the filter and try to understand the process. So in this case, what it is saying that in this particular case, it is passing the white noise through an LTI system, and this LTI system is ideal low pass filter. So this is ideal low pass filter. We know that if it is an ideal low pass filter, then the response of this particular filter will be from minus b to b 0, and this will be 1. So the pass band gain I have considered as 1, and I have considered that it is passing the frequencies up to b and suppressing the frequencies after b. So this is the characteristic of ideal low pass filter. So now let us try to discuss all these things. So first of all, I can write that this n of t will become w of t convolution h of t. This is the mathematical representation to write an output for an LTI system. So this is the first thing which I can consider. Now the second thing which you can notice from here, that this is your white noise, this is output noise n of t, this is the LTI system h of t, h of f. We know all the other parameters such as its autocorrelation function, I can write it as Rw of tau, and its autocorrelation I can write it as Rn of tau. Its Fourier transform will be Sw of f, and its Fourier transform will be Sn of f. So this is the Fourier transform, and in between you are having your Hf, which is having characteristics something like this, minus b to b, this is 1, this is f. We know that whenever we have to write this Sn of f, or the PST of the output, we are going to multiply mod hf square with SW of f. So this Sn of f becomes mod hf square SW of f. So now let us try to understand it. So first of all, you should understand that this SW of f is n naught by 2 from minus infinite to infinite. This h of f is 1 in the range from minus b to b. So obviously the mod of hf square will also be 1 between this frequency b to b, and we are writing the PSD of output. So let us understand it graphically. This was your SW of f versus f, and this value is n naught by 2. Now this particular PSD is supposed to multiply it with this filter, and the response of this filter is mod of hf square. Now let me multiply these two. So whenever you will multiply these two, you will get a rectangular pulse in frequency domain from minus b to b, and whose peak value is n naught by 2. So you can write it as SNF versus f. Or if you have to write mathematically, you can write that Sn of f will be n naught by 2 for mod f less than or equal to b, or it will be 0 elsewhere. So we have obtained the power spectral density of output colored noise, and it is coming out to be minus b to b n naught by 2 rectangular pulse in frequency domain. Now if I have to calculate the autocorrelation function of n of t, so I can write it as Rn of tau. Fourier transform will give us Sn of f. So basically we have to calculate its inverse Fourier transform. We have already studied a result that this sin at by pi t expression in frequency domain gives us minus a to a. This is omega domain 1. So what I will do, I will convert this Sn of f into omega domain, and we have already developed the process to calculate the omega domain. Whenever you have to move from f domain to omega domain, I will multiply 2 pi on the horizontal axis, so it will become minus 2 pi b to 2 pi b, and I can write it as Sn omega, and the zero frequency value is kept as it is. So here zero frequency value was n naught by 2, here also zero frequency value is n naught by 2. So it is converted into minus 2 pi b to 2 pi b, and this value is n naught by 2. So now compare here, this a or minus a is matching with this 2 pi b, and instead of 1 here we have n naught by 2. So its inverse Fourier transform, we can write it as n naught by 2 sine 2 pi b tau upon pi tau. So the autocorrelation function of n of t we obtained as Rn of tau equal to n naught by 2 sine 2 pi b tau upon pi tau. We can also convert it into sinc function, and whenever you have to convert the sinc function, first of all you must forget this sign. So this pi tau gets cancelled out and you get n naught b. Then replace sign with sinc and divide the argument by pi. So you can get the autocorrelation function. So we have got the colored noise, which is the output of this ideal low pass filter, and this colored noise has PSD as rectangular function, and autocorrelation function as a sync function. So whenever a white noise is passed through ideal low pass filter, you always get colored noise. Now this colored noise has PST in the form of rectangular function in frequency domain, and its ACF will be sync function. Now let us try to generate an interesting result. Is that Rn of tau is equal to some n naught b sync 2b tau. We know that sync of x becomes 0 for x equal to k, where k belongs to all the integer and k should not be equal to 0. So if I have to make it 0, I will put 2b tau equal to k, and I will not allow this k to be 0 except it can take all the integers. So from here you can get the value of tau. So this can be 1 by 2b, 2 by 2b, 3 by 2b, and so on, which means if two samples are 1 by 2b duration apart, tau represents the samples of n of t random process are tau duration apart. So this tau basically represents the observation of the samples. Now if this tau becomes some k by 2b, or the duration becomes basically 1 by 2b or 2 by 2b or 3 by 2b between two samples. So if the duration between two samples becomes 1 by 2b, 2 by 2b or 3 by 2b, in all those cases Rn of tau will become 0, and it will represent that samples are orthogonal. We can also say that if we are observing two samples which is n of 0 and n of k by 2b, so we will get Rn of k by 2b, which is always going to be 0. So the samples which are 1 by 2b, 2 by 2b, 3 by 2b duration apart are always going to be orthogonal. Similarly, if I will calculate covariance of samples of n of 0 and n of k by 2b, so it will become expectation of n of 0, n of k by 2b minus expectation of n of 0 into expectation of n of k by 2b. We know that output is also 0 mean random process, and it is also WSSRP. So the mean of the random process and random variable both will be 0. This will give Rn of k by 2b, and this will also become 0. So you can say that the samples which are observed tau duration apart, where tau is k by 2b, will always be samples tau equal to k by 2b duration apart will be uncorrelated, and since n of t is also a Gaussian random process, so they will also become independent. So this discussion is also important, that whenever white noise is passed through an ideal low pass filter, the output will have autocorrelation function as sync, which means if two samples of output random process are observed tau duration apart, where tau is k by 2b, where k belongs to integer and should not be equal to 0, then these two samples will always be orthogonal, or which leads to the statement that they will also be uncorrelated. And we know that since n of t is Gaussian random process, and if two samples are uncorrelated, they will eventually become independent. Now let us move on to the transmission of white noise through practical low pass filter. So till now we have understood that what will happen when we'll transmit the white noise through the ideal low pass filter. So in this case, I am transmitting this white noise. This will be the colored noise n of t. Again, this is an LTI system having h of t and h of f, but in this case, this is a practical low pass filter. For practical low pass filter, we can draw this circuit diagram. So this is your practical low pass filter, RC. This will be the part of the system. Here we are applying this WT, and here we are expecting this N of t. We know that transfer function of the low pass filter is 1 upon 1 plus SRC, or you can write it as 1 upon j omega RC, or HF can be written as 1 upon j 2 pi f RC. Again, if I have to write the power spectral density of output, I can write it as mod of HF square SW of f. Here SW of f, we know that power spectral density of white noise is N0 by 2 for all the possible frequencies. Similarly, HF in this case is 1 upon 1 plus j 2 pi f. So if you will calculate mod of HF, it will become 1 upon under root 4 pi square f square, and mod of HF square will become 1 plus 4 pi square f square. So if I have to write Sn of f, I can write it as N0 by 2 1 plus, sorry, it will be RC will also be there, so it will become R square C square. It will become R square C square. So I can write it as 4 pi square f square R square C square. Now, if you have obtained Sn of f as N0 by 2 upon 1 plus 4 pi square f square R square C square, then if you will take its inverse Fourier transform, then you will get the autocorrelation function. Now, we know that the Fourier transform of e to the power minus a mod tau, where a is greater than 0, comes out to be 2a upon a square plus omega square, or you can write it as 2a upon a square plus 4 pi square f square. So I will convert my expression in this form. So I can write N0 by 2 separately, and let me divide the complete expression by 1 by r square c square. So it becomes 1 by r square c square plus 4 pi square f square. Then again I will take this N0 by 4 times RC outside, so that I can make here this 2 by RC term, due to which it will become 1 by RC whole square, and you can write it as 4 pi f square. Now compare. You can compare that in the denominator there must be a term of a square, So in this case, this A becomes 1 by RC. In the numerator, you must have 2 times of A. So here also we are having 2 times of A, and this 4 pi of F square is common both the sides, and this N naught by 4C is constant. So if I will calculate its inverse Fourier transform, I will get N naught by 4 times RC e to the power minus, instead of A we can use RC, and tau should be present there. So the autocorrelation function of the output comes out to be N naught by 4RC e to the power minus mod tau by RC. So in this case, when we passed white noise through a practical low pass filter, we got the colored noise, and the autocorrelation function of this colored noise came out to be N naught by 4 RC e to the power minus mod tau by RC, and the autocorrelation function comes out to be N naught by 2 1 plus 4 pi square F square R square C square. Now if I have to calculate the mean square value or the variance of output, which will represent its power, it is coming out to be Rn of 0, or you can write it as N naught by 4 RC. Similarly, you can also calculate it by integrating minus infinite to infinite Sn of f df, or minus infinite to infinite N naught by 2 1 plus 4 pi square F square R square C square df. It will always give you N naught by 4 RC. So now you have understood how to pass the white noise through ideal low pass filter and through practical low pass filter. Now let us try to understand the narrow band noise. So the narrow band noise name is also dependent on the process of filtering. So suppose this is again your white noise, and suppose this white noise is now being passed through an ideal band pass filter. So here this is your ideal band pass filter, and we will get output as N of t. This will again act as an LTI system. We'll have unit impulse response H of t or H of f. Now let us consider that the frequency response of this filter is centered at Fc minus Fc, and it is having bandwidth of 2b Hertz. This will be minus Fc plus b minus Fc minus b, and again it will have the bandwidth of 2b Hertz. So this I am assuming that it is the characteristic of the ideal band pass filter. So now, and again the pass band gain here I am considering it as 1. So what will happen? We know that if we have to write the power spectral density of output, so the power spectral density of output can be written like this. Here two things are known. One is power spectral density of white noise, which is N naught by 2, and characteristic of H of f. Based upon that, we have to decide this particular expression. So first of all, I am dealing it graphically. So this is the white noise PST, and it should be constant throughout. so it should be constant, and this value will be n naught by 2. Now I am passing it through a band pass filter. The characteristic of the band pass filter is given, so we will calculate mod of hf square from there. So mod of hf square, since its amplitude is unity, so it will not change, it will remain 1. This will become fc plus b, this is fc minus b. Again, this value will become minus fc, this will be minus fc plus b, and this will be minus fc minus b. So this is the common region in both these graphs. Based upon that, I can plot the output power spectral density, and we have to multiply these two. So first of all, I will multiply it with something like this and this. So this is fc, this is minus fc, and after multiplication it will become n naught by 2. Now if you will observe this particular graph, fc minus b, this is minus fc plus b, minus fc minus b. So you can say that this particular spectrum is representing a narrow band spectrum, because in narrow band spectrum lower cutoff frequency is very much greater than 0, and the ratio of higher cutoff frequency to lower cutoff frequency is approximately 1. So this is your fh, this is your fl, and fh by fl is approximately 1. So since the power spectral density of output noise is narrow band, hence this n of t is also known as narrow band noise. Sometimes it is also known as band pass noise. So whenever you will pass white noise through an ideal band pass filter, the output noise will have spectrum such as a narrow band signal has the spectrum. So you can call this noise as narrow band noise. So this is the case. This is the band pass filter, and whenever the white noise is passed through the band pass filter, the resultant noise at the output is known as band pass noise, because the power spectral density of n of t will have band pass nature. So the output is known as band pass nature, or you can also call it as narrow band noise. Now we know that mathematically a narrow band noise can be represented as n of t equal to nit cos omega ct minus nqt sin omega ct. This I have discussed when I was teaching the pre-envelope or the envelope concept. There I told you that how to write a narrow band signal. So the mathematically a narrow band noise can be represented something like this, and here this nit is known as in phase component of n of t. This is in phase component of n of t, and this nqt is known as quadrature phase component of n of t. NIT can be written as N of t cos omega ct plus N cap t sin omega ct. Similarly, NQT can be written as N cap t cos omega ct minus NT sin omega ct, where N cap t is Hilbert transform of N of t. So this much information we have. Now, since N of t can be written as NIT cos omega ct minus NQT sin omega ct. So we must be able to extract this in phase and quadrature phase components from this narrowband noise expression. So we are actually interested in extracting this particular expressions. So what I can do, I can multiply this N of t with 2 cos omega ct, and I'll be getting the output as say N1t. Then I'll be passing it through a low pass filter. Similarly, here also I will multiply it minus 2 sin omega ct. Say this is N2t. And again I will pass it through a low pass filter, and suppose the output of this is y1t and output of this is y2t, and the characteristic of low pass filter is same in both the expressions, and it is from minus b to b, and let me consider this as 1. So this is the spectrum of low pass filters for both the low pass filters. Now first of all, we know that N of t is NIT cos omega ct minus NQT sin omega ct. So to obtain N1t, you have to multiply N of t with 2 times cos omega ct. So let me multiply it. So it becomes NIT into 2 times cos square omega ct minus NQT sin 2 omega ct. So I basically multiplied this expression with cos omega ct. So now it can be written as NIT plus NIT cos 2 omega ct minus NQT sin 2 omega ct. Now this is the N1t. Now this is being passed through a low pass filter. So whenever it will be passed through a low pass filter, we know that these NIT and NQT are low pass signals, and N of t is band pass signal. So whenever this N1t is passed through the low pass filter, which is allowing only signal from minus b to b, then we are always going to get the NIT. This will be converted into a band pass signal because the spectrum will be shifted to 2 omega c, and this will also be converted into a band pass signal. So these two signals will not be allowed by the low pass filter. So we can recover our in phase component from here. Similarly, if we have NIT as NIT cos omega ct minus NQT sin omega ct. So to obtain N2t, I will multiply N of t with minus 2 sin omega t, and whenever I will multiply it minus 2 sin omega t, it will be converted into NIT sine 2 omega ct plus 2 times nqt sine square omega ct. You can write it as nit sine 2 omega ct plus nqt minus sine square t can be written as 1 minus cos 2 omega ct, so it will become nqt cos 2 omega ct. So I can write it like this: nqt minus nit sine 2 omega ct minus nqt cos 2 omega ct. Again, this n2 of t is passed through low pass filter. We know that this nit and nqt has low pass nature and this n of t has band pass nature. So since this nqt is low pass, and when this nit or nqt is multiplied with carrier, so they will convert into a band pass. It will also become a band pass. So the output will be nqt. So we can all again recover our nqt. Now let us again observe the graph that we passed our white noise through a band pass filter. Then we got this n of t. Then this n of t is passed through two multipliers. One is 2 cos omega ct, another one is minus 2 sine omega ct. Then again we are passing it through a low pass filter. These two low pass filters are same, and here we were getting the in phase component and here we were getting the quadrature phase components. So now let me call this as n12 and this as n22, and the characteristic of this low pass filter is from minus b to b 1. So this is the characteristic of low pass filter. Now I will start from here. We know that power spectral density of white noise is n0 by 2. Here we have band pass filter which is centered at fc and it has bandwidth of 2b. It is centered at minus fc and it has bandwidth of 2 Hz. So this is something like this. Now what will be this Sn of f? This Sn of f will become n0 by 2 mod of hf square. Now what will be the PST of this S1f? So this S1f can be written as, we know that if the PST of n of t is Sn of f, then PST of n of t into 2 cos omega ct will be a square by 4. So this is a square by 4 PST of n f plus fc plus Sn of f minus fc. This standard we know that PST of n of t is Snf, then PST of nt into a cos omega ct will be a square by 4 Snf plus fc plus Sn of f minus fc. Similarly, it can be written as PST of Sn1f. Similarly, if I have to write n of t minus 2 sin omega ct, then its PST can also be written as a square by 4 Sn of f plus fc plus Sn of f minus fc and this can be written as Sn to f. So till now we got N1T signals PST as Sn f plus Fc plus Sn f minus Fc, and let me call it as Sn1f. Similarly, you can get the PST of N2T, which is Sn f plus Fc plus Sn f minus Fc, and you can call it as Sn to f. So this is plus. Now we know that in order to get the PST of in-phase component, you have to pass this N1T through a low pass filter, and this low pass filter is band limited to Bhz, or it is having spectrum something like this. So the PST of in-phase component can be written as mod of HF square and PST of Sn1f. So we know that its passband gain is 1, so it will multiply the given density with 1, but it will restrict the PST in this particular frequency range. So you can write Snf as Sn of f plus Fc, Sn of f minus Fc. Now it will not exist throughout, rather it will exist between this band minus B to B, because the in-phase component is obtained after passing it through a low pass filter, or you can also write it as mod f less than or equal to B. Similarly, you have obtained the PST of N2T. Now this N2T is being passed through a low pass filter. Then you are getting this NQT. The low pass filter has spectrum from minus B to B, and this is your HF, and let me consider the passband gain as 1. So from here the spectrum density of quadrature phase component will be Sn to f. So this SNQF will be same as Sn to f, but this filter will restrict this PST from minus B to B. So you can again write it as Sn of f plus Fc plus Sn of f minus Fc, but this will be limited now from minus B to B, or from mod f less than equal to B. So from here you can say that if you have a narrow band noise such as NIT cos omega ct minus NQT sin omega ct, and if you know the PST of n of t, which is Sn of f, which will be in general mod of HF square into SWF, and this mod of HF square will be obtained from band pass filter, then you can write the power spectral density of NIT, which will be Sn of f plus Fc plus Sn of f minus Fc. It will be SNIF for frequency less than equal to B. Similarly, if I have quadrature phase component, you can write its power spectral density. This is power spectral density, which is Sn of f plus Fc, Sn of f minus Fc, and Snq of f. This will also be for frequency range mod f less than or equal to B. Or you can say that the power spectral density of both in phase and quadrature phase component will be same, and you can write it as SNIF equal to SNQF which is equal to Sn of f minus Fc plus Sn of f plus Fc for mod f less than or equal to B, and it will be 0 elsewhere. So this is very important observation, and you should always remember this observation. And what is B here? B is the band limiting frequency of low pass filter, or you can also comprehend it as half of the bandwidth of band pass filter. So in both ways you can comprehend it like this. So now let us take an example. So suppose I am taking the power spectral density of white noise. So this is the power spectral density of white noise. This is N0 by 2. This frequency is F, and this is SW of F. Now suppose I am making a narrowband noise by passing it through a band pass filter. So the spectrum of that narrowband noise will be S N of F, F, and this center frequency is Fc. This is Fc minus B. This is Fc plus B. Again, this center frequency is minus Fc. Let us consider this as minus Fc plus B, and this is minus Fc minus Fp. This value is 1. Now let me calculate these values. Since it will be 0 means, so expectation of N of t will be 0, because if white noise is 0 mean, then if it is passed to an LTI system, then output N of t will also have 0 mean. Similarly, if I have to calculate expectation of N square t, which is sigma square N of t, because the mean square value will be equal to variance, so I will calculate minus infinite to infinite Sn of f df. So if you will calculate area under the curve of this signal, you will get N0 by 2. This is 2b. This duration is also 2b. So you can write it by 4b, or you can calculate it as 2 times N0 b. So this is the power or the variance of this N of t. Since you know the graph of N of t, so we are interested in the spectrum of SNIF or SNQF, which is Sn of f plus fc plus Sn of f minus fc, that too from minus b to b, and it will be 0 elsewhere. So let me make these two graphs. So first of all, I will make Sn of f plus fc. So whenever you will make Sn of f plus fc, which means you are shifting your graph of Sn fc unit leftwards. So it will become minus b to b. This will become N0 by 2, and here we get again spectrum which is at minus 2fc plus b, minus 2fc minus b. Similarly, you can draw the spectrum of Sn of f minus fc, which means we have to shift the spectrum fc unit rightwards. So you will get one box at 2fc, 2fc plus b, 2fc minus b, and another box at minus b to b, N0 by 2. So simply we have to add these two graphs. So whenever we will add these two graphs, which is Sn of f plus fc plus Sn of f minus fc, so we will get a spectrum from minus b to b, and N0 by N0 by 2 will get added up and it will become N0. We will get another spectrum centered around 2fc, and this will be N0 by 2, and similarly another spectrum which will be centered around minus 2fc, and it will become N0 by 2. Now if we obtain this Sn of f plus fc into Sn of f minus fc, then we know that in order to get the in-phase density and the quadrature phase density, we need this Sn of f plus fc plus Sn of f minus fc from minus b to b only. Rest of the graphs can be ignored, or it can be considered zero elsewhere. So if I have to plot the spectrum of in-phase and quadrature phase components, so I can plot the spectrum as SNIF, it will be equal to SNQ of f, and you will get the spectrum of in-phase or quadrature phase components as minus b to b n naught. Now if you will calculate its mean square value, both the mean square values will be same because the PST is same. So you will calculate minus infinite to infinite SNIF df, and if you will calculate the area under the curve, you can obtain n naught into 2b, which you can see that equal to n square t. So the power content in narrowband noise and their in-phase and quadrature phase component is always same. So now let us try to write the properties. So all these properties are important. All these properties you must remember. So first of all, we had a WT. I passed it through a band pass filter and say the band pass filter has frequency response as h of f. Then we got n of t. Then this n of t got multiplied with 2 cos omega ct and minus 2 sin omega ct. Then we will pass it through the low pass filter. Here also we will pass it through the low pass filter, and we got in phase component and quadrature phase component, and we have already drawn the characteristic of both band pass and low pass filter. So the first property is that the in phase component and the quadrature phase component has same power spectral density, which is Sn of f plus fc, Sn of f minus fc for mod f less than or equal to b, and it will be 0 elsewhere. So this is the first property, where what is b? B is the band limiting frequency of low pass filter, or half of the band limiting frequency of band pass filter. Now second important property is PST of n of t will represent band pass or narrow band spectrum, while PST of NIT and NQT, which both are same, will represent low pass or baseband spectrum. Next property is since WT is zero mean, so N of t, NIT and NQT all will be zero mean. Fifth, since WT is zero mean Gaussian random process, hence N of t, NIT and NQT, all these will also be zero mean Gaussian random process. We also concluded that the mean square value of n square t will be equal to the mean square value of in-phase component, and it will also be equal to the mean square value of quadrature phase component. Since all these three are zero mean random processes, so we can say that the variance of narrowband noise will be equal to the variance of in-phase component will be equal to the variance of the quadrature phase component. Now, the last property is that this n of t is equal to NIT cos omega ct minus NQT sin omega ct. This is also Gaussian random process. This is also Gaussian random process. Now, if I will calculate the envelope of n of t, so it will be equal to under root of ni square t plus n square qt. We know that if this is Gaussian random process, if this is also Gaussian random process, then under root of ni square plus nq square t will have Rayleigh distribution. This we discussed in the random process, you can refer from there. So it will have Rayleigh distribution. So the envelope of the narrowband noise will always follow the Rayleigh distribution. Thank you.
So hopefully we have understood every concept in this class. If you have any doubt in any concept, you can let me know in the comment section. I'll try to resolve that thing. Apart from that, you can also follow me on various social media platforms. For example, you can join this Telegram group where you will be getting important notification, important updates. This is Telegram group where you can also comment, you can ask your queries, or maybe you can also suggest me for the improvement. Apart from that, this is my Unacademy profile. On this Unacademy profile, you should also follow me so that you can get the important updates of the Unacademy also, right? And this is the Notion page. You just have to type this tiny.cc/VishalGate. So you will be redirected to a page where all the special classes are arranged very systematically. तो मैंने बहुत सारे टॉपिक्स पे स्पेशल क्लास ले रखी है. फॉर एग्जांपल नाइक्विस्ट, फूरियर सीरीज, latches and flip flop, double integrations, okay, lot of things are there. So you will be getting all these concepts absolutely free of cost. You just have to type this in your URL, you will be redirected to that page and attend these lectures one by one. You will be getting a next level confidence in these topics, that I can guarantee you. Now this is the Notion page of your YouTube, on which you will be getting the links of the YouTube. Apart from that, you will be also getting the PDFs of that particular lecture. So this is very important for you, and just you have to type http://bit.ly/GateLive. So GateLive, you just have to type it in the capital so that you can access all the lectures link and PDF arranged systematically. So if you want to attend or you want to clear the examination with the free resource, then this is the channel for you. This is the best recorded videos which has been ever made. You just have to go to that lecture, just click the link and download the PDF and start studying systematically. So we have also done this for you so that any student, whether he is sitting any part of this country, should not face the difficulty in cracking the examination, whether he can afford or he cannot. Now if you can afford, then the subscription prices are not something which you cannot pay. It is very nominal amount which you can pay, and you can just avoid all the distractions, all the time wastage which we will be doing in downloading those PDFs, arranging them, arranging for the test series, and a lot of other things that you have to arrange, doubt solvings you have to arrange by yourself. If you want to avoid all those distractions in a very nominal amount, so you can go for the Unacademy Plus subscription. For 12-month subscription, you have to pay only 74 rupees per day. Apart from that, for 18-month subscription, which is the best possible subscription, you have to pay 63 rupees per day. It is even lesser than the pizzas that you order on your home. So it is that much of amount that can shape your career, that can give you the best possible rank in the examinations under the guidance of the best teachers of the country, which has been right now placed on the Unacademy. Now 24-month subscription will cost you 54 rupees per day. So these subscription amounts will give you the subscription for the desired period. Apart from that, if you are using this code, you just have to remember this code, write my name, write GATE after it. You can also write ESE after it. So you have to write my name and write ESE after it. So any one of these code, once you apply, you will be immediately getting the 10% discount. You will be getting all the features of the Unacademy. You will be getting the guidance of all the teachers present on Unacademy, and everything you will be getting that is needed to crack the examination once you are using this code. So if you think we are working hard, we are giving our best content, we are giving the free content absolutely for you guys, and everything that is needed for every student to crack the examination. So never forget to use this code whenever you are taking the subscription. So this code is very important and you have to use every time you are taking the subscription. Now those who are interested for the prices, total price amount, so let me tell you, total price is 27,225 for 12 months, 34,650 for 18, and for 24 months it is 39,600. You can also pay this by using zero cost EMI. Zero cost EMI can be paid by credit card and debit card. In debit cards there are only Bajaj and HDFC as of now available. Okay, so this zero cost EMI means you do not have to pay anything extra. Any interest is not, you should not pay, and you have to pay this much of amount on the daily basis if you are looking for the zero cost EMI option. Apart from that, if you are coming for Iconic subscription, so Iconic mein, I have already told you that your personal coach will be the game changer. He will be he will be basically following you to give you the guidance so that you can get the success in a very short span of time. So he will be following you, he will be pushing you every time. Now once you use this coupon code, this will be costing you around 45,225, and if you are using this coupon code, write my name, GATE after it, you will be getting the 24-month subscription of Iconic in 66,600 rupees. Fine. Apart from that, every one of you should follow this GATE aspirant group, and there also some important notification always comes. Now what are the YouTube channels that you should immediately subscribe? This Kreatryx, this is the channel on which you are present. This is Unacademy GATE questions, where previous year questions has been solved by the educators. So you'll be getting all the previous year questions video solution apart from the PDF also. This is the Electrical Junction channel, where you will be getting the important concepts of ECE and electrical, and this is Engineering Pathshala, where you will be getting some practical aspect of the videos, some animated videos that will enhance your ability to think. So these are the channels which you should immediately subscribe so that you can get a better content. Fine. Now these are my some YouTube videos which I have created for you. In all of these videos will give you some motivation, guidance, content, and some strategy. So these are hand-picked videos. You can immediately follow these videos. Okay, so thank you so much, and those who are coming on this channel, immediately share all the content which is present on this channel. We are working very hard for you guys, so this is your responsibility that you should share this channel, you should subscribe this channel, also share the link of this channel, link of the videos, link of the educator whom you follow, so that every student who is needy, they can come onto this channel and they can get the best possible rank. So all the best everyone, let's crack it.